Hi everyone, I welcome you all to the wonderful video lecture on human-computer interaction. And now we'll talk about HCI, human-computer interaction in the software process. And myself, Shankar, I'm working as an assistant professor in the Department of Computer Science and Engineering at RMD Engineering College, Chennai. This software process is involved in the following subtopics, right? Um, Software engineering and the design process for interactive systems. And next, we'll see about usability engineering in the software process, iterative design and prototyping. And finally, we conclude with design rationally. Let us see, let us see the software life cycle. What is software engineering? We know that we have seen the software lifecycle method with software engineering. A software engineering, a software engineering is a process, or software engineering is a large sub-discipline that addresses the management and technical issues of the development of software systems, right? And the software lifecycle describes the activities that takes place from the initial concept formation for a software system up until its eventual phasing and the replacement. So finally, what we conclude with the software engineering is as a discipline for the process of understanding the software design process or a life cycle method. Designing for the usability is occurs at all the stages of the life cycle. It's not involved in the single isolated activity. And next, we'll see the waterfall model in the software design, software life cycle. There are many activities are involved in the life cycle method in the waterfall model: requirement specification, architectural design, detailed design, coding and unit testing, integration and testing, operation and maintenance. It involves various activities. Let's see detailedly for each activities what it is involved. Let us see first the requirement specification. The requirement specification, the designer and customers are try to capture the description of what the eventual system will be expected to provide. And the requirements are usually initially expressed in the native language of the customer. And next one is architectural design. It specifies how the system provides the services expected from it, and it decomposes the systems into components that can be either brought in the existing software products, or it can be developed from the scratch independently. It also determines the independencies between separate components and the sharing of resources between the components. The next activity from the waterfall model of the software process is detailed design. The detailed design is a refinement of the component description provided by the architectural design. The next level is coding and testing. It is the detailed design for a component of the system. It should be taken and implemented by some executable programmable language. After coding, the component can be tested. The next phase is integration and testing. It is actually individual components that have been tested must be integrated. Testing is then done to ensure the correct behavior of the system. Acceptance testing is then done with the customers to ensure that the system meets their requirements. And the next one is, the last one is maintenance. Maintenance is involves the correction of errors in the system, which is discovered after release, and the revision of the system services to satisfy requirements that were not released during the previous development. So this is actually overall the process and activities involved in the waterfall model or the life cycle methods. And that these are the listed what activities will be involved in the waterfall model of the life cycle. And next one, we'll see about verification and validation. As Boehm told, validation is as designing at the right thing, and verification is designing the right, designing the thing right. Verification of design will most often occurs within a single life cycle activity or between two adjacent activities. Validation of a design demonstrate that within the various activities, the customer requirements are satisfied. So it has some management issues have been happened with this. That means the life cycle model describes only about a technical feature of software development. In a technical discussion, managerial issues of design such as time constraint and economic forces are not as an important. In management perspective, of a system, it needs a training, the availability of skills and possible subcontractors is taken into an account. Next, we'll see the interactive systems and the software lifecycle model, the waterfall model, what drawbacks actually we are facing with the waterfall model and how it has been overcome. Right? The actual design process is iterative in the sense whenever we have find any drawbacks in middle of this activity, we can again refine the product at each stage, right? At that stage itself we need not to, but if we are compared with the waterfall model, that will not be possible because the everything will be completed and finally it goes to the product level. We cannot identify any mistakes what happened in the middle of the activity, but that will be overcome here because of iteration at each time of the design, whether it may be architectural design or recommend specification or detailed design, any of the activity. If we have found any mistakes, we can again iterate and we can refine the product, right? So that is actually given here, right? It cannot assume a linear sequence in the sense it's completely going on, right? It cannot iterate. So it is not assume a linear sequence of the activities in this waterfall model because we had a lot of feedbacks with this model. And next we'll talk about the usability engineering. The ultimate test of usability is actually based on the measurement of user experience. Based on their user experience, they have given the usability test. And next, the usability engineering demands that specific usability measures be made explicit as requirements. And it requires some usability specifications. The first one is usability attribute or principle. It is a particular usability attribute of interest. The next one is measuring concept. It is an abstract attribute is made concrete by describing in terms of the actual product. The next one is measuring method. The measuring method states that how the attribute will be measured. The next one is now level or worst case or planned level or best case. It means that now level indicates that the value for the measurement with the existing system. The next one is worst case. Worst case value is the lowest acceptable measurement for the task, providing a clear distinction between what will be acceptable and what will be unacceptable in the final product. The next one is planned level. Planned level is the target for the design. And the last one is best case. Best case is the level which agreed to be the best possible measurement. And next, we are facing some problems. We are facing some problems with the usability engineering. The first one is usability metrics. It means that the usability metrics is that they rely on measurements of very specific user actions in very specific situations, and it provide a means of satisfying usability specification and not necessarily usability. The next one is parts of usability specification in VCR. The attributes are backward recoverability. The first one is measuring concept. The measuring concept undo erroneous programming sequence. The next one is measuring methods. It's the number of explicit user actions to undo current program. The now level is no current product allows such an undo. The worst case, as many actions it it takes to program in mistake. The next one is planned level is a maximum of two explicit user actions. Best case is only one explicit cancel action. It has a usability standards 9241. It adopts the traditional usability categories like effectiveness, efficiency, satisfaction. The effectiveness means can you achieve what you want to? Efficiency in the sense can you do it without wasting your effort? Next one is satisfaction. Do you enjoy the process or not? And some metrics are given from the ISO 9241. There is comparability with usability objective, effectiveness measure, efficiency measure, satisfaction measure. So if you talk about the usability objective as suitability for the task, its effectiveness measure is percentage of goals achieved. The efficiency of measure is time to complete a task. Its satisfaction measure is rating scale for satisfaction. Suppose the usability of objective is appropriate for trained user. Its effectiveness measure is number of power features used. Its efficiency measure is relative efficiency compared with an expert user. Its satisfaction measure is rating scale for satisfaction with power features. For the next one, learnability, its effectiveness is percentage of functions learned. Its efficiency measure is time to learn criterion. Its satisfaction measure is rating scale for ease of learning. And next one is error tolerance. Its effectiveness is percentage of errors corrected successfully. Its efficiency time spent on correcting errors. Its satisfaction measure is rating scale for error handling. The next one is iterative design and prototyping. An iterative design process tries to overcome the inherent problems of incomplete requirements specification by cycling through several designs, incrementally improving upon the final product with each pass. An interactive design is described by the use of prototypes. There are main three prototypes are there. The three main prototypes are throwaway, incremental, evolutionary. Throwaway prototyping in the sense the prototype is built and tested. The design knowledge gained from this exercise is used to build the final product, but the actual prototype is discarded. And next we'll see about the incremental prototype. The incremental prototype is the final product is built as separate components one at a time. There is one overall design for the final system, but it is partitioned into independent and smaller components. The final product is then released as a series of products, each subsequent release including one more components. And the last one prototype is evolutionary prototype. This types of prototype is not discarded and serves as the basis for the next iteration of the design. In this case, the actual system is seen evolving from every limited initial versions to its final release. And with this iterative design and prototyping model has some management issues. Management sides, it has some issues. The first one is time. So what issue we are facing with the time is the building prototype takes more time. Building of prototypes takes more time. The next one is planning. Most project managers do not have the experience necessary for adequately planning and costing a design process which involves prototyping. And next one is non-functional features. Non-functional features in the sense to concentrate about safety measures and reliability, the perfect response times, and so on. The last one is contracts. It means that The process of design is often governed by the contractual agreements between the customer and designer, which are affected by many of these managerial and technical issues. So these are the problems we are facing with the management sides. And the next one is techniques for prototyping. For this prototyping, we have three types of techniques. One is storyboards, and another one is limited functionality simulations, and the last one is warning about iterative design. Let us see one by one how these are. The first one is storyboard. This is the simplest notion of a prototype. This is a graphical depiction of the outward appearance of the intended system without any accompanying system functionality. Modern graphical drawing packages can be used to create storyboards. Effective animation can be done by automated sequencing through a series of snapshots. Animation illustrates the dynamic aspects of the intended user's system interaction. Right? And next one we'll see limited functionality simulations. Some part of the functionality must be simulated by design team. There are plenty of prototyping tools are available which allows the rapid development of such simulation prototypes. One among them is HyperCard. One among them is HyperCard. It is a simulation environment for Macintosh line of Apple computers. And another technique for simulation which does not require very much computer supported functionality is the Wizard of Oz technique. Oz technique. With this technique, the designer can develop a limited functionality prototype and enhance its functionality in evaluation by providing the missing functionality through human intervention. The next one is high-level programming support. That is warning about interactive design. So the HyperTalk was an example of a special purpose high-level programming language which makes it easy for the designer to program certain features of an interactive system that expense of other system features like speed of response, space efficiency. The next one is warning about the iterative design. The design decision made at very beginning of the prototyping process or wrong end. In practice, design inertia can be so great as never to overcome an initial bad decision. If a potential usability problem is diagnosed in the process of evaluation, it is important to understand the reason for the problem and not just detect the symptom. Next one, we'll see about the design rationale. Design rationale is the information that explains why a computer system is the way it is. It includes structural, architectural description, and functional or behavioral description. Next, we'll see that design rationale has several advantages or benefits. Right, the first one is communication among the members of a design team throughout life cycle. And the next one is reuse of design knowledge across the product and enforce design discipline. Next one presents arguments for design trade-offs. The next one organizes the potentially large design space. The next one capture contextual information. Next, we'll see there are two types of design rationale. One is process oriented and another one is structure oriented. There are two examples for each one. There is process oriented and structural oriented. The first one is issue based information system and another one is design space analysis. We'll see what is process oriented design rationale, right? So the process-oriented design rationale is preserves the order of deliberation and decision-making. And about the structure-oriented design rationale is emphasizes post hoc structuring of considered design alternatives. Let us see the example for process-oriented design rationale. that is issue-based information system. Already we had two examples for this design rationally. Issue-based information system is the example for process-oriented design rationally. And another one is design space analysis. It is the example for structure-oriented design rationally. So let us see the issue-based information system. IBIS, issue-based information system, is the basis for much of design rationally research, and it is the process-oriented design rationally. It has mainly it has three main elements that are issuers, positions, and arguments. Issuers are the hierarchical structure with one root issue. Position are potential resolutions of an issue. Arguments are modifying the relationship between positions and issuers. So we have GIBIS. It is a graphical version of IBIS. The structure of the design rationally is in the form of a directed graph, which can be directly edited by the creator of the design rationally. So this is actually depicts with this diagram. And issuers of this is the positions, issuers and positions arguments or the node in the graph, and the connections between them are labeled to clarify the relationship between the adjacent nodes. Next, we'll see about design space analysis. This design space analysis is the example of structure-oriented design rationally. The questions represents an agreed characterization of the issuers raised based on the reflection and understanding of the actual design activities. This approach is based on questions, options, and criteria, that is QOC, question, options, and criteria. This QOC notation, which is a hierarchical structure, questions and sub-questions represents major issues of design. Options provide alternative solutions to the question. Criteria specifies the measure, and criteria specifies the means to assess the options in order to make a choice. That detailed specification diagram is given here. Our next one is psychological design rationally. The psychological design rationally supports task artifact cycle in which user tasks are affected by the systems they use. It aims to make explicit consequences of the design for users. Designers identify the task the system will support. Scenarios are suggested to the test task. Users are observed on the system. Psychological claims of the system is made explicit. Negative aspects of the design can be used to improve next iteration of the design. So thank you all of you for watching this video lecture until now. Right, so thank you for all. For any comments, please tell me. Okay, thank you all.